Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 4th grade topic, changing mixed numbers into improper fractions. More specifically, we're going to be going over how to do it, how to remember it, and why it works. As always, if you have any question about what you see here today, or even your own homework, feel free to either put them in the comment box below or visit me on Facebook at Tutor Me Sempai. When you find this video helpful, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, without further ado, let's change some mixed numbers. So the first thing we're going to be talking about is how do we change a mixed number into an improper fraction? Well, the first thing you need to know about that is an improper fraction is going to have the same denominator as the mixed number. So in this case, we have a 4 in the denominator for a mixed number. We automatically put that 4 in the denominator for our improper fraction. Now that we have that step out the way, we can move on to the next step, and that's where the fun happens. In order to find the numerator of our improper fraction, we're going to have to multiply the denominator times the whole number, and then we're going to take that result and add it to the numerator of our mixed number. So what that looks like is 4 times 3, so 4 times 3, put that in parentheses, and then take that and add it to 1. So we did 4 times 3, whatever that equals, add it to 1, and that's your numerator. So what's 4 times 3? Well, that's 12. Plus 1 over 4, which equals 12 plus 1, 13 over 4. This means 13 over 4 is our improper fraction. So let's recap. The first step was to find what's our denominator for our improper fraction. Well, that's going to be simple because it's always what the denominator was for our mixed number. So you just simply write it over, and that is your first step. The next step is taking that denominator, like we did here, multiplying it by the whole number, and then whatever that equals, we add it to our numerator that was in the mixed number. That's how we got this numerator here, and when you did all the math, we got 12 plus 1, which equaled 13. So our improper fraction is 13 over 4. So that's how we do it. Let's see how we can remember this, because this seems kind of wild, right? How are we going to remember to do everything that we just did here? Let's check it out. In order to help us remember this, you might see some people refer to the C method, in which you draw a C, and that will help you remember, because you're going to be taking this path from the bottom to the top. However, this doesn't really help me. Personally speaking, when I draw a C, I always start from the top to the bottom. Now that might confuse me because starting from the top and going to the bottom is the exact opposite of what we need to do when we're changing a mixed number into an improper fraction. So I don't really like the C method because you have to remember to go from the bottom to the top. And I don't really write my C's like that. You may, so it could help you, but personally, that doesn't really help me. I like to think of the stair method. If you were to go into a building, you come in through the first floor, right? So our first floor is going to be our denominator. We already know what that is. We already discussed the denominator has to be the same. So we go on the first floor and we're trying to get to our top floor, our numerator. But we need to go to all the steps first. So we're going to take our steps and then go up the stairs this way and then up the stairs this way. And then we're going to be in our numerator. We're going to find out what our numerator is. So I like to think of the stair method, going from the denominator to the numerator, but we have a stop in between. Now you might be asking yourself, how do we remember which order to do our addition and multiplication? Do we do addition first and then multiply, or is it multiply and then add? Well, we can still use the stair method to help us here too. Imagine you going into a building and you go on the first floor. You jump into the building and you're on the first floor and you need to go all the way to the top. Now you might start really fast to get up the stairs quickly. And whenever I think of getting up the stairs quickly, I think of multiplication. When you're multiplying two numbers together, you are increasing very fast. 3 times 4 is 12. 3 times 5 is 15. And you see you're jumping by 3 every time. You're going so fast. Unlike addition, when you're adding numbers, you're increasing slowly. And I like to think after I've been running up the stairs a bit, I might slow down a little bit. So instead of going as fast as the beginning, when I multiply two numbers, I'm increasing slower when I add two numbers. So the first stairs, I'm multiplying, going very fast up the stairs to get to the top floor. Then I get a little bit tired, and then I go a little bit slower, but I'm still going up the stairs. I'm still increasing, I'm still going up the stairs, but I'm going a little bit slower. So I'm adding the numbers instead of multiplying the numbers. So that's how I remember these. So we start at our first floor, our denominator, and then we go up the stairs, and we're going to our whole number. You see, the stairs goes to the whole number. And we're going to go very fast, so we're going to multiply these two numbers. 3 times 4. And then once we're on this floor, we're not quite at the top floor yet, right? So we got to go up some more. So we're going to keep going until we get the numerator over here, but we're not going to go as fast. We're a little tired. So we're going to take what we found on this floor, the 3 times 4, our 12, and we're going to add it to this numerator, and that's how we got the 13. So we talked about how to do it, and we talked about how to remember it, but why does that even work? What is a mixed number that would work? Well, our mixed number is really just a different way of writing our fraction. So the denominator is going to control what our fraction is going to look like. We're going to have something that's cut into 4 pieces. So I'm going to draw the circle here, and I'm just going to cut it into 4 pieces. So this is what helps us understand what this looks like. So we have a 1/4 here. So what does this 1/4 mean? I'm gonna just isolate these two, and I'm gonna try to do it in different colors so you can see the difference between what I'm about to draw. So this 1/4 is gonna be in green. 1/4, so we shade in just a little piece of this circle. That's gonna be our 1/4. So we know what this equals. And this 3 here, let's change that color to be our blue, so that we don't get confused with the two pieces. So what does this 3 mean here? 3 as a part of this mixed number here might look a little confusing. So let's rewrite that in different terms so you can see exactly what it means. Whenever you have a mixed number, let's say 3 and 1/4, that's really just saying 3 plus 1/4. So you have 3 wholes, and instead of another whole, you have a 4th here. So this 3 is just going to be 3 wholes. But since we're talking about 1/4 here, our denominator 4 is going to control what these wholes look like. How many pieces are these going to be cut into? Since there's a 4 here, each one of these wholes is going to be broken into 4 pieces. And since they're wholes, not fractions, every piece is going to be shaded. So if 1/4 was this little shaded piece here out of this, then 3 is going to be all of these. We have 3 wholes and we have 1/4. Now if we were to add up all of these here, all these shaded regions, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 shaded regions, but we have to keep our same denominator. We have 12 regions, and each whole is broken into 4 pieces. So that's what this 3 means, 12 over 4. So when you add all of these, how many shaded regions do you have? So this gave you 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But we have an additional shaded region here. So we actually have 13 shaded regions, and everything here is broken into 4, so we're going to keep that 4. So this is why it works the way it does. Whenever you have a mixed number, this whole number represents how many fully shaded regions we have. Everything is shaded in these pieces. And this fraction here lets you know how many we have that are shaded out of the last piece. It's not going to be a whole, or it would have been added into this, so we have something left over. We only have 1 piece out of the whole 4 pieces that could have been shaded. These are fully shaded, this is not, and we're just adding up all the shaded regions. That's what an improper fraction is doing for us. is telling us how many fully shaded regions we have and how are those regions broken up. So now that we talked about how to change a mixed number into an improper fraction, how to remember to do that, and why does it work, let's make sure that we understand everything that we went over with a few more examples. So you see here, we have 2 and 7 tenths. Now I draw it like that so you can really emphasize the stair method. You want to go up the stairs and you want to stop at the first floor. So we're going to use the stair method to change this mixed number into an improper fraction. So we draw stairs from our ground floor to our first floor, and then we draw more stairs from our first floor to our top floor. We already know what the ground floor looks like, right? It has to have the same ground floor. As we go to our first floor, we're going to go up fast. We're really energetic. We're running up the stairs, so we're going to go fast. Multiply, move fast. So that's going to be 10 times 2. So we're going to write that here. 10 times 2. And then put that in parentheses, so we hold on to that. Now that we made it here, whoa, that was a lot of running. We're a little bit tired, but we still got to get to our top floor. So we're going to go just a little bit slower. We're going to add this time. So we're going to take the 10 times 2 that we just did, and we're going to add it to 7. So what is 10 times 2? Well, that's going to be 20 plus 7. And what's 20 plus 7? Well, that's 27. And that's how we're going to use a stair method to change this mixed number into an improper fraction. Let's do one more example. Using a stair method here, how are we going to convert this into an improper fraction? So we draw stairs. And we're going up very fast, right? So the first stairs, we're going to be multiplying, and we're going to slow down a little bit. And so we're going to add for the second stairs. We already know what our ground floor looks like. It has to have the same denominator, so we just write that. And then when we do this, it's going to be 5 times 2. Put that in parentheses, 5 times 2. And then we're going to add the numerator, which is 3. So what's 5 times 2? Well, that's going to be 10 plus 3 all over 5. And then what's 10 plus 3? That's going to be 13. So when we convert this, when we change our mixed number into an improper fraction, we get 13 over 5. So I hope you're able to follow in today's examples. Now, if you had any questions whatsoever about your own homework or what you saw here today, feel free to either put them in the comment box below or visit me on Facebook at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember, leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.